In this tutorial, I'll be talking about scientific notation and dilution math. First, just a little bit on why this is important to do, especially for you with your career goals. It's important to point out that in medicine, numbers are important. They can be the test results from diagnostic tests. They can be dosages for drugs, whether we're talking about tablets or IV drips. And the exact value of a number can determine what diagnosis is made or make the difference between life and death in the case of a dosage. So if you want to be involved in medicine, it's important to be kind of aware of numbers and be sensitive to them, and really to look at them and think about, what a number is, what it means, and be able to double check it and recognize when something is wrong. Scientific notation is often used in science and engineering. It helps you to look at numbers with a more critical eye and see differences between numbers that might otherwise look similar. And so it's worth learning scientific notation, and you may need to use it for your classes and in standardized tests and other places. That will be important for you as you pursue your goals. In scientific notation, a number is represented by a coefficient times a base raised to a given power. The coefficient is always a number between 0 and 10, and it has the information on exactly what the value is. If the coefficient is negative, then we're talking about a negative number. So if you're trying to express a negative number in scientific notation, you would put a minus by the coefficient. The base and the power tell you roughly how large the number is. It gives you the order of magnitude or the ballpark value. So for an example, 100 in standard notation is 10 times 10, and therefore it is 10 raised to the second power. So it's 10 times itself. And to go from standard to scientific, you can simply count the zeros in that value. The rest of the examples you can try for yourself, and then at the end of the document you'll be able to see how you did and get the answers there. For a number that's given in scientific notation, if you want to go back to standard, for example, if you want to key it into a calculator, the same principle applies. So 10 to the fourth, start with a 1 and then add 1, 2, 3, 4 zeros. And if it helps you to see those numbers, you can put in the comma there and see that you have 10,000. Okay, so to go from base 10 with a power to a standard number, you just write a 1 and add the number of zeros matching the exponent there. Okay, so now we know a little bit about that, and we can think about how to actually get the scientific notation for a specific number. Sorry about the numbering there. To do that, you are going to start with a number. You're going to shift the decimal to the left until you have a number between 0 and 10. Then you're going to write the coefficient, leaving out any of what I call trailing zeros, and I'll show you what that means in a second. And then the exponent on the 10 is going to be the number of spaces you moved. So let's start with the example of 7,342,000. I want to shift the decimal to the left till I get a number between 0 and 10. So in this case, it would be 7.342, and after that, those zeros won't be written down. Times 10, and now I have to figure out the exponent. Well, to get to 7.342, I had to move the decimal 1, 2, 3, 4, 5, 6 places to the left. So it would be times 10 to the 6th. Another quick example, just because this might throw you off. How would I write this one? 120.02. Well, I start 1.2, right? Because that's between 0 and 10. But now I have to include all this information, 002, 002. And times 10 to what power? Well, I had to shift the decimal 1, 2 to get 1.2002. I had to shift the decimal over 2 places to the left. All right, so it would be 10 squared. And here are some examples that you can do and try for yourself. What if you are given scientific notation and you want to express that as a regular number? How would you do that? Well, in that case, you want to start with the number you're given, the coefficient, and write 1, 2, 8 out. And then we have to shift the decimal over by that many places. So in this case, it would be 3 places. 1, 2, I'm going to need one more 0. So it would be 1,280. So in other words, you just write out the coefficient and shift the decimal over that many places to the right, whatever the power is of 10. A little more challenging for some people is to understand how fractions are represented. It's important to remember a fraction is not a negative number. They're greater than 0, but they're less than 1. And a fraction is created by dividing a number by a larger number. And in scientific notation, we represent fractions with negative exponents. So 1/10 is 1 divided by 10. If you were to get out a calculator and do that, you'd see the decimal, of course, is 0.1. And now we have to figure out what the exponent is. And in this case, it would be -1. So if we divide by 10 once, the exponent is -1. 1 over 100, we're dividing by 10 twice. 1 divided by 10 divided by 10 again, right, to get to 1 over 100. And that's 10 to the -2. You can do the rest. So the general procedure for decimals is to shift the decimal to the right until you have a number between 0 and 10. That's your coefficient. Write that number, including all the digits, but no trailing zeros. and then the negative exponent is the number of spaces you moved to the right. So for 0.700, what that really is a fraction. It's 7 divided by 10. And the coefficient is 7, right? That's a number between 0 and 10, times 10. And what would the exponent be? Well, to get from 0.7 to 7, we need to shift over 1 to the right. So it would be 10 to the negative 1. All right. So what that really means is just 7 divided by 10. 10 to the negative 1. Instead of multiplied by 10, you're dividing now. The next number down might be a little bit of a fooler to you when you just first look at it. But what you should pay attention to is the ballpark. Just like this one is 0.7, this one's also 0.7. You just have some additional information on the precise value after that, and you have some trailing zeros. So that'll be good practice for you to try. What if you're given a number in scientific notation and you want to recover standard notation numbers so that you can, say, plug it into your calculator or something? For the example of 1.08 times 10 to the negative 3, we can start by writing a 0 and a point. Because this is a negative decimal, we know it's going to be a fraction. So we'll start with 0 and a decimal to get us into a fraction less than 1. Then we have negative 3. So let's see. In order to get to the actual value, we have to shift the decimal to the left 1, 2, 3 places. So 1, 2, 108. And then I can verify that I got it right. It was 1.08 when it was written scientific. Shift over 1, 2, 3, and we get 0.00108. Okay? So what we did was we shifted the decimal to the left until we had a small fraction which matches 10 to the negative third. All right, 1, 2, 3 spaces there.